Hey, Math 20-2. Today we're going to do a quick review of factoring. Recall, factoring involves writing a sum or difference of monomials as a product of polynomials. In this lesson, we're going to review factoring techniques in previous math courses, namely taking out a common factor, factoring by differences of squares, and factoring trinomials by inspection. All right. We're going to focus on factoring quadratic expressions of this form. All right. Start off factoring quadratic expressions where a is 1. So this is going to be 1x squared plus whatever you want, bx plus c. So to geo-correctly write the quadratic expression, x squared minus 8x plus 12 in factored form is x minus 6x minus 2, using the method of inspection. Explain how this process works. Well, what Joe did was ask herself, what two numbers have a sum of the middle term, minus 8, and a product of the last term, 12? The two numbers that add to negative 8 and multiply to 12 are negative 6 and negative 2. So she used those two numbers as the factors of x squared minus 8x plus 12. All right. We're going to use that same procedure in example 1. Factor the following by the method of inspection. There's a 1 in front of the x squared term, so I'm just going to make my two sets of brackets. The only way to get to x squared is to put an x in the front of each bracket. And you ask yourself, what two numbers have a sum of the middle term 13? So what sums to 13 and multiplies to 30? The two numbers that add to 13 and multiply to 30 are positive 10 and positive 3. And you factored x squared plus 13x plus 30. That's the method of inspection. All right, part B. Again, 1x squared minus 13x minus 30. We can make our two sets of brackets. The only way to get to x squared is to put an x in the front of each bracket. What two numbers now have a sum of negative 13 and a product of negative 30? Well, minus 15 and positive 2. Those two numbers add to negative 13 and multiply to negative 30. Part C. Again, there's a 1 in front of the x squared term, so we can use inspection method, make your two sets of brackets. Ask yourself, what two numbers have a sum of the middle term, minus 11, a product of the last term, 30? Now, if you get stuck doing these, just write down all the things that multiply to 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't multiply to 30, 5 times 6. So which of these, if I could, would ever add or subtract to 11? Well, 1 and 30 would give me 31 or 29. 2 and 15 is 13 or 17. 3 and 10 would be 13 or 7. That just leaves me with 5 and 6. So I'm going to put my x in front of each bracket to get x squared, and then I'm going to use the 5 and the 6. Those are the only things that multiply to 30 and add to negative 11, so it's going to be minus 5 and minus 6. All right. Factoring ax squared plus bx plus c when b equals 0, meaning there is no x term. So you're going to have ax squared plus c. There is no second term. Explain how to factor the quadratic expression x squared minus 16 using the method of inspection. Well, you would ask yourself, what two numbers, if I wanted to write it as in the full form, x squared minus 0x, or you could say plus 0x, doesn't matter, plus or minus 0x, minus 16. Ask yourself, what two numbers have a sum of 0 and a product of negative 16? So you make your two sets of brackets, put an x in the front of each bracket, and what two numbers multiply to 16 and add to 0? Well, they have to be the same number. So 4 times 4 is 16. One has to be positive, one has to be negative. Plus 4 minus 4 adds to 0, and plus 4 times negative 4 multiplies to negative 16. State three other values of c for which the quadratic expression x squared minus c can be factored over the integers, meaning they're going to be positive or negative whole numbers. That's what integers are. All right. So any other values of c that we can think of where the middle term would add to 0. In other words, they have to be perfect squares. So c could be 25. 5 times 5 is 25. 5 minus 5 is 0. All right. You could say c could equal 49. 7 and 7 is 49. 7 minus 7 is 0. So any perfect square for C, 144, and so on, any of the perfect squares. So explain why this method is referred to as factoring a difference of squares. Well, if you think of it, x squared minus any of these numbers, the first term, x squared, is a perfect square. And C, if you want to factor it as a difference of squares, C must also be a perfect square. So if both those terms are perfect squares, we're going to factor as a difference of perfect squares. Difference because there's a subtraction sign between. We can never factor a sum of squares, only a difference of squares. So use the difference of squares method to factor the following quadratic expressions. A quadratic expression is an expression that has a degree 2. All right. So x squared minus 49, both these terms are perfect squares. All you have to do is make your two sets of brackets. Put the square root of x squared in the front of each bracket, put the square root of 49 in the back of each bracket, and make one positive, make one negative. X plus 7 times x minus 7, that's the factors of x squared minus 49. T squared minus 64, make your two sets of brackets. Square root of t squared is t, square root of 64 is 8, make one positive, make one negative, and you factored t squared minus 64. 25x squared minus 1, are both these terms perfect squares? If so, you can factor as a difference of squares. Square root of 25x squared is 5x, put that in the front of each bracket. Square root of 1 is 1, put that in the back of each bracket. Make one positive and one negative, and you factored the difference of squares. Part D, make your two sets of brackets. Square root of 100x squared is 10x, put that in the front of each bracket. Square root of 81 is 9, put that in the back of each bracket. Make one positive, make one negative, and you factored a difference of squares. Next type of factoring, I'm going to look at common factoring, where there's a common factor, so probably the coefficient of the x squared term is going to be a common factor. So the quadratic expression 2x squared minus 50 does not appear to be factorable using difference of square technique because 2 and 50 are not perfect squares. However, if we take out or remove a common factor from the original expression, we're going to be able to factor this. So 2x squared minus 50, if I factor out a 2, that means I'm going to divide both those terms by 2. 2x squared divided by 2 is 1x squared, and negative 50 divided by 2 is a minus 25. Aha! Now in brackets, x squared minus 25, those are both perfect squares. The square root of x squared is x, you can put that in the front of each bracket. The square root of 25 is 5, that's going to go in the back of each bracket. Make one positive, make one negative. You now have the factors of 2x squared minus 50. 2 times x plus 5, x minus 5. So, as a note, when factoring a quadratic expression, always take out a common factor first if you can do that. Write the following quadratic functions in factored form. So now we're dealing with functions like last unit. F at x equals 5x squared minus 20. Well, 5x squared and 20 are not perfect squares, but if I take out the common factor of 5, divide both terms by 5, I get x squared minus 4. And x squared minus 4 is a difference of squares. The square root of x squared is x, that goes in the front of each bracket. The square root of 4 is 2, that goes in the back. Make one positive and make one negative, and we factored that quadratic function. Part B, g at x. Again, now it's a 3-term expression, but there's a common factor between all 3 terms. 2x squared plus 16x and plus 30 all can be divided by 2. So factor out that 2, that gives me 1x squared plus 8x plus 15. And now, because I factored out that 2, I can use the inspection method we looked at the start of this unit. The only way to get to x squared is an x in the front of each bracket, and what two numbers have a sum of 8 and a product of 15? So what are things that multiply to 15? 1 times 15, well that won't add to 8. 3 times 5 multiplies to 15, well that adds to 8. There we go, plus 3 and plus 5 are our factors. C, h at x is 16x squared minus 64. Let's factor that. Looks like it's got a common factor. I can take out a common factor of 16. That leaves me x squared minus 4. And from there, I know that x squared and 4 are both perfect squares. So the square root of x squared is x, the square root of 4 is 2. Make one positive, make one negative, and we factored h at x. Do the same thing for p at x. I see that all three terms are divisible by 3, but I can actually divide out a common factor of negative 3. That means I've got a 1x squared in front, which is a lot easier to factor a positive x squared term. 6x divided by negative 3 is a minus 2x, and 9 divided by negative 3 is a minus 3. And I'm going to use that inspection method. Make your two sets of brackets. There's only one way to get to x squared, so I put an x in the front. Ask yourself, what two numbers have a sum of negative 2 and a product of negative 3? Well, there's only one way to multiply to 3. That's 3 times 1. If I want to get a sum of negative 2, that has to be negative 3 plus 1 adds to negative 2. Negative 3 times 1 multiplies to negative 3. All right? Note, in the next two sections, we review a process necessary for factoring quadratic expressions of the form ax squared plus bx plus c when a isn't 1. This technique for factoring is covered in detail in the next lesson. All right? So a binomial common factor. If I'm going to factor ax squared plus bx plus c where b isn't 1, we're going to be required to move a common factor which is not a monomial but a binomial. That's a two-term expression. So let's just review a common factor as a binomial. All right. I've got 3x times x minus 9, subtract 2 times x minus 9. You may want to expand this out, but this question is asking us to factor. So if I'm asked to factor, I don't want to multiply through the brackets. I want to look for something common between these terms. And I notice x minus 9 is common between these terms. So I'm going to factor out that binomial of x minus 9. And factoring out means I'm going to divide. So 3x times x minus 9 divided by x minus 9 just leaves me with 3x. And negative 2 times x minus 9 divided by x minus 9 just leaves me with a negative 2. And that's factored now. I factored out the common binomial factor of x minus 9. I'm left with 3x minus 2. I look at part B. I see the common binomial factor of 2x plus 1. I factor out the 2x plus 1, and that leaves me 5x plus 7. Part C, I notice there's a common binomial factor of 2x plus 1 again, so I factor out that 2x plus 1. 9x times 2x plus 1 divided by 2x plus 1 leaves me with 9x. And 2x plus 1 divided by 2x plus 1 leaves me with 1. Anytime you divide something by itself, you get 1. There's my factored form. 3 minus 2x and 3 minus 2x is a common binomial factor, so I divide out the 3 minus 2x. If I divide that out of the first term, I'm left with 8. If I divide that out of the second term, I'm left with positive x. And we factored out a common binomial factor. So now if you take out a common binomial factor, we can factor by grouping. All right? The method of grouping is another component of the method used to factor trinomials of the form ax squared plus bx plus c when a isn't 1. So it's a more complex method. Factor the following polynomials by grouping. So there is nothing common to all four of these terms in part A. X squared plus 4x plus 6x plus 24. Nothing uncommon. So I'm going to group the first two terms, and I'm going to group the last two terms. I'm going to factor each grouping. So the common factor of x squared plus 4x is an x, and that leaves me x plus 4. The common factor of the last two terms is a positive 6, and that leaves me x plus 4. If I divide both terms by 6, I get x plus 4. And now it's just like the stuff we were looking at before. I've got a common binomial factor of x plus 4. So I divide out that x plus 4, and I'm left with x plus 6. And I factored that 4-term expression by grouping. So we usually factor 4-term expressions by grouping. All right. So the common factor of 2x squared minus 8x is a 2x. 2x squared divided by 2x is x. Negative 8x divided by 2x is a minus 4. I look at the last two terms, positive 3x and minus 12. they have a common factor of positive 3. So 3x divided by 3 is 1x, negative 12 divided by 3 is a minus 4. If things have worked out, you should notice a common binomial factor. And that common binomial factor in this case is x minus 4. So I factor out the x minus 4, and I'm left with 2x plus 3. And we factored by grouping. Let's look at part C. Common factor of 8a squared and minus 4a. I can take out a 4a. 8a squared divided by 4a is 2a. Negative 4a divided by 4a is a minus 1. I look at the last two terms, plus 2a minus 1. Well, there's nothing common there, so anytime there's nothing common, you still factor out a 1. So 2a divided by 1 is 2a. Negative 1 divided by 1 is still minus 1. I now have a common binomial factor of 2a minus 1. So I'm going to factor out 2a minus 1. I'm left with 4a plus 1. And you're done factoring by grouping. Let's look at D. Common factor of the first two terms. Looks like it's going to be a 3x. 6x squared divided by 3x is 2x. And negative 9x divided by 3x is a minus 3. Look at your last two terms, the common factor of negative 4x plus 6. Usually if the first terms are negative, negative 4x plus 6, I'm going to factor out a negative sign. The common factor of 4 and 6 is 2, so I'm going to divide every term by negative 2. So negative 4x divided by negative 2x is 2x. Positive 6 divided by negative 2 is a minus 3. If that works, you should have a common binomial factor. In this case we do. That common binomial factor is 2x minus 3. So I divide out the 2x minus 3. I'm left with 3x minus 2. Last one, E. Group the first two terms. First two terms have a common factor of 8x. Divide both terms by 8x. 16x squared divided by 8x is 2x, and minus 8x divided by 8x is a minus 1. I look at this last two terms, negative 2x plus 1. They have nothing in common. But like I said in this question, if that first term is negative, it's usually good to factor out the negative sign. And I said earlier, if they've got nothing in common, like up here, we still take out a 1. So now I'm going to take out a negative 1. So I divide both terms by minus 1. Negative 2x divided by negative 1 is a positive 2x. And positive 1 divided by negative 1 is a minus 1. That works really nice because now I have a common binomial factor of 2x minus 1. So I've got 2x minus 1. Take out that binomial factor, I'm left with 8x minus 1. And I've completely factored that expression. Great, you guys have your assignment. Numbers 1 through 15. Away you go.